will soon launch from NASA's Kennedy Space Center on the Artemis 1 mission. That launch will send an uncrewed Orion spacecraft beyond the moon and back to Earth. It's the first flight of the Artemis program, which will return American astronauts to the moon and pave the way for exploration of Mars. The Space Launch System will be the most powerful rocket in the world and is the only rocket that can send the Orion spacecraft, astronauts, and supplies safely beyond the moon in one launch. Now, we first tested this core stage on January 16th. That marked a major milestone, firing all 4 RS-25 engines together for the first time for about a minute. However, it ended earlier than planned, so NASA and Boeing decided to do a second test. Teams have been working hard to get to this point, and the test countdown actually started a couple of days ago. Here to update us on where things stand is NASA Public Affairs Officer Catherine Hamilton and Headquarters Green Run Manager Bill Robel in one of our test control centers here. Catherine?
Thanks, Lee. We're inside a secondary test complex outside of the control room, and we're listening in to provide you updates as the team progresses through their steps for this operation. We believe we're within about 45 minutes of the hot fire. The team actually started 2 days ago powering up the avionics on March 16th, and they checked out all the systems that they had tested on previous tests. Earlier this morning, they conducted a go-no-go poll to proceed into the test, and I have Bill Robel here with me to tell us a little bit more. Bill, can you tell us about how the operations have progressed today?
Yeah, sure will. So at this point, we've been in kind of replenish mode for both the liquid oxygen, liquid hydrogen. We've got, at this point, 540,000 gallons of liquid hydrogen on board and another 200,000 gallons of liquid oxygen on board. And they're in the conditioning process right now where we're trying to get that temperature down as low as we can, get it within the start box. And we're also doing the same thing on the engine side of things. And what's important about all of this is that, this timeline that we're going through here will help inform the operations that will take place down at Kennedy Space Center, where not only do they have these things to worry about, but then they've also got to do the things where they're getting people on board and taking care of all the other extraneous things that they have to do down there. So for us here, right, we've also been monitoring things like the battery charging. They're basically up to speed at this point. And then we've got the redundant inertial navigation unit wet checkout, which is basically mounted up in the LOX dome area. And so they're looking to see how it behaves relative to the low temperatures that we're seeing now in that compartment. And so at this point too, the teams are basically looking at all their data, making sure that their systems are where they're supposed to be and ready to go for proceeding into the terminal account.
Thanks, Bill. And can you tell us a bit how the timeline is different for today's test than for a launch, and how is determining the time of the hot fire different from setting the time for a launch?
Yeah, so for us, it's actually we're in a pretty good spot. We're trying to at this point maximize the amount of commodities that we've got here in the test facility. So we're playing a little bit of a game where we've got crews that have been on for a number of hours, and at 12 hours roughly, they'll time out. We want to make sure that we don't have to end the operation any earlier than that, so we're really trying to maximize that. So they're in the process of working that with the nitrogen and helium, liquid oxygen, and liquid hydrogen. The other part of it is, right, the beauty of us is we're in a test. We're not going anywhere today. And so we don't have a destination. Our destination is right here. And so the difference right at Kennedy is they've got, the orbital mechanics, their destination as to where they're going to go. And so they have to work basically all those details in to their exact launch window. Our launch window is basically when we start the test, and that doesn't matter too much today. But they do have they've got a real time hack that they have to hit. So they'll have built-in holds into their process and procedures down there, and that'll inform them kind of how they move through the next steps. We just are fortunate we don't have to worry about that today.
Great, thanks. So that means that we don't have a specific hot fire target time right now at this moment, but we'll keep listening in and we'll provide updates. We do know that the test remains to be projected within the test window, and we believe we're within about 45 minutes. And so we'll continue to listen in here, and I'll turn it back to Lee.
Thanks, Catherine and Bill. And we will come back to you in just a few minutes, like you said, to take us all the way to the test, or sooner if you have any updates for us. We will be listening in, and I'll head right back to you if you do. Now, if you are just joining us, welcome. We're live at NASA's Stennis Space Center in Mississippi, and we're following the second Green Run hot fire test of the Space Launch System rocket's core stage. The core stage is the center core of the rocket that includes 2 propellant tanks and 4 RS-25 engines, miles of cables, all of the avionics, electronics, computers, the brains of the rocket, and all of the plumbing that work together to launch the rocket during the first 8 minutes of the mission. The green in Green Run refers to new, untested rocket hardware. So this is a comprehensive series of tests of all the core stage hardware for the SLS rocket to demonstrate it's ready for launch, culminating with today's hot fire. The core stage will power every SLS mission. So this test is important not just for Artemis 1, but for all future SLS launches as well. Those RS-25 engines are expected to fire up shortly here at Stennis Space Center. Before that happens, let's get a closer look at the Space Launch System rocket.
Super heavy lift rocket and provides the foundation for human exploration and scientific missions to the Moon, Mars, and beyond. Powered by 2 solid rocket boosters and 4 RS-25 engines, this rocket provides unprecedented power and capability. Designed to reach 23 times the speed of sound and an altitude of more than 100 miles in just over 8 minutes. Offering more energy, volume capacity, and payload mass than any rocket built today. Under the launch abort system, Orion, and the upper stage, and between 2 solid rocket boosters is the heart of every SLS configuration, the core stage. Towering 212 feet with a diameter of 27.6 feet, and storing 537,000 gallons of liquid hydrogen and 196,000 gallons of liquid oxygen, this is the world's largest core stage ever built. The core stage for Artemis 1 fires up for the first time at NASA's historic V2 test stand.
The core stage was designed by NASA's SLS program at our Marshall Space Flight Center in Huntsville, Alabama. Then built by lead contractor Boeing using state-of-the-art manufacturing just down the road at NASA's Michoud Assembly Facility in my hometown, New Orleans. It includes engines manufactured by Aerojet Rocketdyne, with contributions from more than 1,100 large and small businesses in 44 states. It was shipped up here to Stennis on the Pegasus barge in January of last year, and then installed on the B2 test stand where you see it here today. Engineers then began activating the stage's components one by one and taking it through the series of tests that make up the Green Run over the past year. Each test built upon the previous one and added a little more complexity. So today's hot fire builds on all of that work for a full test of the entire integrated system that will simulate all parts of the core stage working together during launch. Today's test will take us from extreme cold to extreme hot as the team loads cryogenic or super cold propellants into the fuel tanks and then fires up the engines to drain the propellant from the tanks to simulate launch. Now, the hottest part of the test today will be those 4 RS-25 engines at the bottom of the core stage. These RS-25s we are testing today are repurposed from the shuttle program. These 4 engines flew on some pretty iconic shuttle missions, including one of the Hubble Space Telescope servicing missions, the historic return to space of Mercury astronaut and Senator John Glenn, 6 flights to the space station, and the final shuttle space mission in 2011. so you can trace a direct line from that final shuttle flight to the first flight of SLS. We've worked with our partners at Aerojet Rocketdyne to upgrade the 16 shuttle main engines, which will power the first 4 Artemis flights. And now we're building 24 new engines using 3D printing and other manufacturing innovations to reduce cost, complexity, and manufacturing time. Of course, all of this work is building towards that Artemis 1 launch from Kennedy Space Center later this year. Here's a closer look at that mission and how it paves the way for future exploration beyond.
3, 2, 1, 0. Mission liftoff.
Artemis 1 will lift off from Launch Pad 39B at NASA's Kennedy Space Center in Florida with 8.8 million pounds of thrust provided by the most powerful rocket in the world, our Space Launch System rocket, or SLS. The uncrewed flight will be the first integrated test of SLS, our new Orion spacecraft, and exploration ground systems at Kennedy. Artemis 1 will send Orion beyond the moon, 280,000 miles from Earth, farther than any human spacecraft has ever flown.
This is not NASA doing this. This is the United States of America doing this program, the Artemis program, and there are companies all across our country that have a part in it, so there is kind of this wave of excitement being generated just by saying, we're going back to the moon.
After the upper stage of the rocket separates from Orion, the upper stage will deploy small satellites over several days to perform science experiments and technology demonstrations. Orion will make its multi-day outbound trip to the moon, propelled by a service module provided by the European Space Agency. Engineers will test Orion's systems on the way to the moon. Then, Orion will fly about 60 miles above the lunar surface, using the moon's gravity and engines on the service module to enter a lunar orbit. After about a month and a total distance of over 1 million miles, Orion will return home, faster and hotter than any spacecraft has before. A primary goal of Artemis 1, ensure Orion safely returns to Earth before we fly with humans. When we do, we'll build our capability for sustainable lunar exploration, preparing us for missions farther into the solar system.
Initially, what we'd like to do is start establishing a presence on the moon. So we're going to establish going back there on a regular basis, and then we'll end up setting up Gateway, and we would launch to the Gateway, and from Gateway land on the surface of the moon.
We are there for, weeks, months on end. And there we're going to be able to test out all the hardware and the habitats and the hatches and the suits and the rovers that'll allow us to prove out those technologies. The moon will lead the way to Mars, and we should be there, within the next couple of decades.
Just amazing. And now we are going to hand things over to Catherine and Bill again in the control center. Catherine?
Thanks, Lee. We are in the secondary test control and outside the control room here listening in so that we can provide you updates. Bill, can you give us an update on how things are progressing?
Yeah, so they're in the process now of going through the final checks. Everything's really nicely going really great today. So everything's right on schedule, nominal. They're trying to do this thing what they call right now is jump the clock, which is trying to work it a little bit ahead. So they're in the process of resetting the clock and making sure that when they get to that 10-minute point that it doesn't continue to count down, because that's where they have to go to that pole well ahead of that. So they're working on setting that stuff up right now.
All right, so we'll continue to stand by and listen and provide updates. And as Lee mentioned earlier, the team previously conducted a hot fire test in January. The engines did shut down earlier than planned during that test, but the January 16th test successfully completed several operations for the first time. They were able to transition to the automated launch sequence operated by the core stage flight computer and the Green Run test software. They completed the terminal countdown sequence that is like the launch countdown. They also pressurized the tanks and delivered the propellant to the engines and demonstrated the performance of the core stage's main propulsion system, firing the engines at 109% power, and they operated the thrust vector control system that steers the engines. So it's a smooth countdown so far today, and we'll keep standing by. We'll take a pause for you for a moment, and we'll check back in just a few minutes. The B1, B2 test stand that you're seeing there is a dual position vertical firing facility with the B1 side equipped for single engine tests and the B2 side designed for rocket stages. The stand is anchored to the ground with 144 feet of steel and concrete. We talked a little bit about the history of the RS-25 engines, and the B2 stand, which is where the SLS core stage is secured now, also has quite a bit of history. It was used in the 1960s to test Saturn V rocket stages that carried humans to the moon during the Apollo program, and the Space Shuttle main propulsion test article, consisting of an external tank and 3 main engines linked together with a simulated shuttle orbiter, was also tested on the B2 stand. The B2 stand has been modified to test the SLS core stage for the Artemis program that will return humans to the moon, with a new steel superstructure added for testing the SLS core stage. The stand is now almost 350 feet high, ranking it as one of the tallest structures in the state of Mississippi. For a little bit more about the RS-25 engines, each of the RS-25 engines is about the size of a compact car if the engine were turned on its side. Standing up, they are each 14 feet tall and 8 feet in diameter. They each weigh about 8,000 pounds. The RS-25 is designed to operate in extreme temperatures from negative 423 degrees Fahrenheit to 6,000 degrees Fahrenheit. And as Lee mentioned, today's test will go from extreme cold to extreme hot. When the hot gases exit the RS-25's nozzle, they travel at 13 times the speed of sound, which is fast enough to travel from Los Angeles to New York City in about 15 minutes. The core stage itself stands 212 feet tall and at a diameter of 27.6 feet. And weighs about 2.3 million pounds when loaded with propellants. So the next major milestone coming up will be the poll for the terminal count. It's the last 10 minutes of the countdown. Bill, can you tell us a little bit about what we can expect to hear during the terminal count?
Yeah, so just ahead of terminal count, we'll hopefully get that call. They'll do a poll, which is all the members of the team basically getting their go for going into that terminal count sequencer. And then once we actually get into it, there's at least 500 different events that take place in that last 10 minutes. So I'll not go through each one of those with you, but there are some pretty good ones I think that highlight, kind of what the major ones should be or are. We've got to terminate the hydrogen replenish, and then we've also got to go into the hydrogen tank pre-press operations, which is where they'll pressurize the hydrogen tank. It'll start doing that on its own as well. Initiate ground helium spin start supply to the CAPUs. So initially when the CAPUs come up, they'll be running off of the helium supply in the stand, and then it'll switch over to the engines when they come up as part of the plus count.
Can you tell us a little bit about what the CAPUs are?
Yeah, so that's the core stage auxiliary power units. They're variants of the ones that were flown on shuttle. The difference is that where those were hydrazine powered, these are basically run off inert gas and then into hydrogen off of the engines when they get into the plus count. So it's basically a turbine system that spins a pump, and that pump then in turn pressurizes the oil in that system. And through a series of valves and commands, they could then go ahead and actuate the actuators that are mounted to each of the engines in pitch and yaw. After that, we'll get into liquid oxygen terminate, and liquid oxygen replenish will stop that operation. And then we'll go into CAPU starts, and that's where each one of those core stage auxiliary power units will be powered up. And that takes, on the order of about 30 seconds to bring each one of those units up. They're done individually. And then they basically move into transitioning into the LOX tank pressurization operations. They do a TVC gimbal profile on helium, so that's actually something different that you won't see in the plus count. In other words, we do a lot of actuation of the TVC system in that, but we don't move it as far because of the limits we've got in the stand for how far you're moving it relative to having the engines burning at that time. So in the pre-count, we'll basically get the full movement, the full gimbal, full displacement, and then once they get into the plus count, they will not do that, but they'll do some other things. And then after that's complete, they'll basically bring the actuators into their null positions. Basically, they'll go ahead and make sure the engines are ready to go ahead and start. They will then transition the core stage to internal power. They do have, with the redundant inertial navigation unit, they've got the gyro compass alignment that they'll finish up. And that's when we get into the next big sequence, which is the go for the automated launch sequencer, and that'll start roughly at 33 seconds. So that's kind of the big steps that take place up to that point. And what happens once we get into that ALS is that if we have to recycle, then that's a big deal. It's probably not something we can recover from that easily on day of. But ahead of that, we can basically recycle back to the 10-minute mark, and then it would take us probably an hour or two to get back into position where we can go through it again, but that's kind of how the day would look.
Thank you. So it sounds like the majority of the calls are actually going to come in the last 5 minutes of the terminal count. And so we're waiting to hear when we are ready for the poll for the go, no go into the terminal count. So we'll stand by for a little bit here, and then we'll come back when we have another update. For the Artemis 1 launch, there will be a built-in hold before the go, no-go pull to go into the terminal count with the last 10 minutes of the countdown. This isn't quite the same, but it is similar. The team takes a look at the data from the vehicle and the facility and ensures that everything looks good before proceeding into the terminal count. So we're just a little more than 10 minutes away from our T0 time now to fire up the engines. And when those engines fire up, the team is looking to get at least 4 minutes of data to support the test objectives needed to confirm that SLS is ready to launch Artemis missions. From there, they will continue to let the engines fire and to burn through all of the fuel in the tanks and possibly pick up additional data for some secondary test objectives. During launch and ascent for Artemis missions, we expect the engines to fire for about 8 minutes to drain the tanks of the propellant before what is called the main engine cutoff, or MECO. So, Bill, tell us a little bit about what we can expect after hot fire starts.
Okay, so the other thing I'd say is I'm also listening in, so if we get to the point where they're going to call for the poll, I'll just tell you to pick it up at that point. But so where I left off was with the ALS start, so that's roughly 30 seconds before they actually start. We would then bring on the hydrogen burn-off igniters, which are basically a series of flares that are built into the stand to pick up any residual hydrogen and basically dissipate all that. They'll finish with the renew redundant inertial alignment navigation mode, and then basically they go into, at roughly 6 minutes, they'll do the RS-25 starts, and those they bring up one at a time, and roughly at 5-6 seconds they'll start that. At 1 second they'll be up and running at 100%, and with that, I think we're getting ready to hear them go for the poll. But as they basically get through that part of it, we'll hear the basically the engines will come up to 109% thrust level, and then we'll go into the first poll at the gimbal profile. So I think what we should do at this point is switch over, if we can, to pick that part of it up.
All right, let's listen in to the poll.
That's the correct time pack as the sequencer steps through there. Reminder to everybody, after we get past 557 and after we terminate LH2 system securing, we only have 2 minutes 35 seconds at full time before we have to recycle pack. Also, another reminder to everybody, when we do the switch to internal power, we will get the Christmas tree effect on the avionics screen. So that is normal, that is to be expected. So just to remind everybody that we will get that Christmas tree effect once we go into internal power. All right, sequencer, on your command, let's go ahead and initiate the terminal count sequencer for substep alpha and record the UTC time, please. Copy.
T count has resumed.
And give us a UTC real quick, please.
20, 2712.
Copy, 077, 20, 2712.
You copy?
T-minus 9 minutes.
All right, it sounds like we actually missed the poll, so we are in the terminal count sequence now, and we are standing by and listening as they progress through their steps.
T-minus 8 minutes. T-minus 7 minutes.
Oh, that's place your quarter since it continues.
And we're about 6.5 minutes away from hot fire right now.
And T-minus 6 minutes, starting LH2 securing. T-minus 5 minutes, initiating TVC spin start.
So at this point, they've basically initiated CAPU start, and basically those will be coming up on helium. They'll go into a what we call the wiggle test, which is where they'll gimbal the engines, and then so that's basically coming up here in just a couple of minutes. On the plus side of that, once we get into the engine starts.
T-minus 4 minutes, CAPU start, starting LO2 securing.
Okay, so LO2 is being secured now, so that they're really moving forward in the plus count here. Still roughly at T minus. .42 And so with that, we should be seeing the TVC gimbal profile here in about half a minute or so. Basically at this point they've got the water system all turned on. Maybe we'll see that in some of the views, and that'll basically take care of not only the heat coming off of the engines, but also dampen the tremendous amount of noise that'll be coming off. As mentioned earlier, the hydrogen burn-off igniters will come on at about 12 seconds.
T-minus 3 minutes starting PSN 4.
The inertial navigation mode will be complete at about T-minus 10 seconds. And then basically the enable command for ALS at 9.2 seconds. And then we go into engine start at roughly at 6 seconds. Those take about 5 seconds to come up to full operating pressures. And basically at that point, the stage controller will be go for launch, or go for test in this case, at 2 seconds. And basically we go forward into our profile for the day.
All right, we're coming up on 2
Here's
minutes.
the gimbal test taking place now.
T-minus 2 minutes.
So the call was they just announced at T-minus 2 minutes, which is basically they have finished the gimbal test with the actuators and they're bringing them back into the null position. And then basically at this point they basically are getting ready for powering up the engines. Again, core stage transitions to internal power at roughly 1 minute and 30 seconds out.
T-minus 1:30, switch to internal power.
And then if renew gyro compass alignment converges at roughly 1 minute. And then we'll have the go for ALS. And we'll clear that polar shortly at T-minus 33 seconds.
T-minus 1 minute following personnel report go, no go for ALS, AEA, PEA,
Go.
AGA,
Go.
REA,
Go.
NEA,
Go.
NTC. Vehicle and speech systems are go for ALS.
And at this point you see basically the water system has come on full bore.
All right, T-minus 30, we're in ALS.
And you just got the official start of ALS. Next up is the hydrogen burn-off igniters come on at 12 seconds before T0.
Red line back there. H-boys on.
Go for engine start.
H-boys are on and engine starts has been okay.
And all personnel, we've got engine start and we're to the plus count. All personnel, please continue to monitor your system and grass is in control. Starting TBC profile number 1. Again, first now we've got a fire. Let's go ahead and do TF. TF. Okay, copy. Do you want me to hold down ATF? I copy that. Cancel it out. Yeah, starting the FRT full line. Keep us 4 minutes 30 seconds. I should in the FRT profile. Hot mic on 16. What's 5 minutes?
We're just over 5.5 minutes in the plus count.
About 6 minutes. Starting from Michael 16. Yeah, I'm not seeing any T6C violations, so I got the really good. Thanks, sir.
We're coming up on 7 minutes of the plus count.
T plus 7 minutes. plus 7 minutes 30 seconds there. PBC profile number 2. Plus 8 minutes. And then the PBC profile number 2.
All right, so we're just over 8 minutes into the plus count.
Personnel is coming up hopefully on the last completion here, and we have a cut-off. All right. REA, can you verify REA on channel 16? REA on channel 16, verify. Safe engine shutdown, please.
Safe engine shutdown.
And you're in post shutdown standby, correct?
Correct.
Okay, all personnel, that takes us to page 656. All personnel go to page 656 to start the post-hot fire shutdown securing operations.
All right.
Okay, all personnel on page
Bill, as you said
656,
earlier, as we talked about earlier, the team was hoping to get at least 4 minutes of data. And we All right, they are proceeding with their shutdown procedures now. As we said earlier, the team was hoping to get at least 4 minutes of data, and they did get more than 8 minutes, excuse me. So they should have gotten what they need. The team will obviously need to look at that data, but based on what we've seen, Bill, tell us more about what it looked like to you.
Yeah, so they clearly got the full duration that they were after, which is really great news, and I think you heard the applause. They had, the commanded shutdown, which is exactly what they were looking for. They had no TCC violations, test commit criteria violations that would have prompted an early shutdown. So that was really good news. Clearly there's a lot of data that's going to have to be analyzed. The engineers got to see what worked and what didn't, or what needs to be tweaked and what doesn't. But that said, I think the applause says a lot about how the team feels, that they got through the test, and it looks pretty good right now. Yeah, so there was some, observed burning on the aft end. One of the things that Boeing had done after the last test was to apply a lot of extra cork to the aft end, because we aren't going to. We didn't, unfortunately, with this test, right? We're not flying through the thin air as we ascend, and so we knew we were going to have more of that, and that was one of the reasons why they added that. They also put a tape covering over the top of that. We knew that if the tape gets hot enough, that adhesive layer below the tape surface is going to start burning, and so we clearly saw a lot of that. But there was nothing that prompted shutdown early, which was really good news.
Great, thank you, Bill. I think that's all the updates that we'll have for you here as the team proceeds through their shutdown procedures. So we'll turn it back over to Lee.
Thank you, Catherine. Congratulations to the team. So as the engineers gather the data from today, we look ahead to the next steps. This core stage will be refurbished and sent by barge to our Kennedy Space Center in Florida. There, it will be stacked in the iconic vehicle assembly building with other elements of the SLS rocket, including the twin solid rocket boosters, which our teams have already begun stacking on the mobile launcher. The core stage and boosters will then be stacked with the upper stage and the Orion spacecraft. All of this work putting us on track to roll out to Launch Pad 39B for a liftoff later this year on Artemis 1. We've got several other firsts on the horizon. This year, the first of our commercial lunar payload services, or CLPS missions, begin with 2 companies delivering instruments to the lunar surface. The golf cart-sized Viper rover will search for water at the moon's south pole. And a small CubeSat called Capstone will head to the moon, scouting the orbit to be used on later human missions. Meanwhile, the hardware for the next 2 Artemis missions, which will carry astronauts to the moon, is coming together. The Orion spacecraft for Artemis 2 is down at Kennedy undergoing assembly, and the spacecraft for Artemis 3, as well as the rockets for Artemis 2 and 3, are also being manufactured right now at Michoud. So that wraps it up for us here today. After a major milestone on America's return of astronauts to the lunar surface, a successful test of the core stage of the Space Launch System rocket. Up next, we'll be replaying the test, and we will have a post-test briefing in about 2 hours here on NASA television. We invite you to follow all of our progress online at nasa.gov/Artemis program, or join the conversation online with @NASA Artemis and @NASA_SLS. Thank you for joining us, and go Artemis.
And all personnel, we've got engine start, and we're into the plus count. All personnel, please continue to monitor your systems, and grass is in control. Plus 60 seconds starting TBC profile number. Again, first now we've got a fire computer there. We're going to go ahead and ETF. ETF. How many do you want me to hold down ETF? I can't do that. You can't pull it out. Profile, remember. Starting the FRT profile. We're still good. That's a facility issue. And it's a good one. Puts 4 minutes 30 seconds. I should end the FRT profile. Lightning 16. What's 5 minutes?
We're just over 5.5 minutes in the plus count.
About 6 minutes. Over there from Mike 16. Yeah, I'm not seeing any TCC violations, so I'm comfortably good. Thanks, John.
We're coming up on 7 minutes of the plus count.
T plus 7 minutes. And T plus 7 minutes, 30 seconds, start TBC profile numbers. T plus 8 minutes. And then the TBC profile number 6.
All right, so we're just over 8 minutes into the plus count.
Well, personnel is coming up hopefully on the last depletion here, and we have a cutoff. All right. REA, can you verify REA on channel 16? REA on channel 16, safe engine shutdown, please.
Safe engine shutdown.
And your input shutdown standby.